Hello, today we start from Calculus 7 and then we will continue with Calculus 8. This is week 4. Calculus 7 is about the local and global extrema. What's that mean? Aim of this topic is find the points x and y in some region D for which a given function f x and y attains its maximum and minimum values. I think you remember that in 2D dimension, two-dimensional graph. Let me just, okay. When you have a graph such as this, I call it y equal f of x. As you know, this is x, this is y. This point, you have also this point. You call this one before local minimum, minimum, and this one we call it local maximum. It means you find a critical point when f prime x is equal 0. Now this one variable as a x. Now we want to think about the function of the two variables. Now suppose f x and y is a function of two variables. And the goal of this point is find the highest and lowest point on z equal f x and y. Okay, first step. Find places when the tangent plane is horizontal. Look at here, you have a line in horizontal point. For the two variables, you need a tangent plane in horizontal position. and critical points x naught, y naught, where fx x naught, y naught equal fy x naught, y naught equal 0, or fx x naught, y naught, or fy x naught, y naught doesn't exist, do not exist. You should mention those points. Okay. Now let's see what is the local maximum in two variables. What is the local minimum, and what is the saddle point. If at a critical point, critical point, if x and y less than or equal f x naught, y naught. This point is called the local maximum. And if at a critical point, f x and y more than or equal f x naught, y naught, then you have a local maximum. And for a smooth function, if a critical point is not a local maximum or a local minimum. For example, let me show you one example. X 5x plus 2 3y minus 2 and exp power x2 plus y2 x2 plus y2. It's better put in the bracket and 1 more bracket divided by 5. Okay. Now plot this one. No, that is x comes from x x times bracket times bracket times. Okay, don't worry, I will show you with this. I copy this one, paste here. Okay. You can see I can
Yeah.
maximum, local minimum, and look at this point. It look like the something like this, not maximum, not minimum, but it's a critical point. I can call this one as a saddle point. Okay. For example, if x and y is equal to x3 plus x plus 1 y squared plus 5x2, find all critical points of this function. What should we do? Okay, first of all, we use the want to check critical point f of x naught y naught equal f of y xy equal 0. We want to check this one. Okay, f of x is equal round after x 3x2 plus x plus 1 y squared plus 5x2. At this point, you think that is no y is the constant, then derivative to respect to x would be equal 6x plus y2 plus 10x. This one equal 0. Respect to y. Now, for the respect to the y, I write f of y, round after y, 3x2 plus x plus 1, y square plus 5x2. Now, respect to the y, you think the x is the constant. This is 0, this is 0, just remain this one. It looks like 2y x plus 1, and this is equal 0. Okay. This is equal 0 if x plus 1 0 or 2y 0. It means x equal minus 1 or y equal 0. Now, keep this one and back to this point. If suppose x equal minus 1, then check in this equation. 6 minus 1 plus y square plus 10 minus 1 equal 0. It means that the y square would be equal 4, y equal plus and minus 2. Okay, you have this critical position. X minus 1, y plus 2 and minus 2. It means that the critical points are minus 1, 2 and minus 1, minus 2 is the first one. Now check for the y equals 0. Y equals 0, back to this equation again. We suppose y equals 0, it means 6x2 plus 0 square plus 10x equals 0. It means that the 2x, 3x plus 5 equals 0. It means that the x equal 2x equals 0 or 3x plus 5 equals 0, x 0 or x equal minus 5 over 3. You find two critical points again. The first critical points are 0 and 0 and minus 5 over 3 and 0. Okay, we can say critical point for the dysfunction, in total we have 4 critical points. That is 0 and 0, minus 5 over 3 and 0, minus 1 and 2, minus 1 and minus 2. Okay, if I plot this equation, two x power 3 plus bracket x plus 1 close bracket y over 2 plus 5x over 2 again. Two x power 3 x plus 1 for x power 2. Okay. If I plot this one, let me copy. Okay. Look at C. You have a here local minimum, local maximum, and this point would be saddle point and saddle point. If I show you the contour plot, here, copy, paste, you can see better here. You know, this is 2 points, these 2 circles. One of them is darker, one of them is lighter. Lighter is the lower, darker is the lower, darker is the lower part, lighter is the higher part. This point would be 0 and 0, local minimum. This one would be the local maximum, would be minus 5 over 3 and 0. And these 2 points, you know, not just is the critical point, but not the minimum, but it's not the maximum. This point and this point would be 1, minus 1 and 2. This point would be minus 1 and minus 2. This would be the saddle point. And this one would be the saddle point as well. And if we need a second derivative to show that is the local maximum or local minimum without using the graph. Derivative test to figure out what sort of critical points we found. If you use the second derivative, it means that you don't need to use the graph. Okay, another example. F of x and y, 3x minus x3 minus 2y2 plus y4. Find the critical then derivative of x is means that you think the y is constant number and you use the derivative of x. Okay, it would be equal to 3 minus 3x2. If I put this one equal 0, it means that the 1 minus x2 equals 0. It means that you have x equal minus and plus 1. And if you put the derivative of the y, round of the y, 3x minus x3 minus 2y2 plus y4 equal to minus 4y plus 4y3. I put this one again equal 0. It means that I can factorize 4y minus 1 plus y2. It means that the critical point is y equals 0 or y equal plus and minus 1. Okay. Now we find the 6 critical point. y6, because you have a 3y 2x. 3 times 2 is 6. You have a x1, you have a x, again 1, 1 with 0, 1 with minus 1, and 1 with 1. Then you have a x minus 1, 0, 1, minus 1, minus 1, and minus 1 and 1. You have a 6 critical points here. If I plot this one again, 3x minus x 3 plus minus 2y over 2 plus y over 4. Come on. And x minus x power 2 times y power 2. Come on. Okay, let me plot by my hand, doesn't matter. If I'm going to show you the contour plot, would be such a this. Okay, you have a 6 point. This point, this point, this, 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 and this point. You know here, this one, if I show you in the graph, would be 1 and 0. This one would be -1 and -1. This one would be 1 and 1. This one is 0 and -1. And this one, no, this one would be 1 and 1. This one would be 1 and -1. This one would be, I show you 1 and 0, 1 and 1, -1, -1, 0, -1, 1, and -1, 1 and -1, and -1 and 1. Okay. These 3 points are, this one is local minimum, local maximum, and again local minimum, because in the middle of in the center of the circle of the contour is, if they show the dark one, it means low, light one is means the up, if I show in the contour properly. And this point, no maximum or minimum, they are saddle point. Let me check it doesn't come. No. Okay, now we use the second derivative test to find which point is the local minimum, which one is the maximum, which one the saddle point. If we don't have access to plot, we can decide that which point is the minimum, maximum, or saddle point. It is the theory here. The second derivative test. In second derivative test, if you have this one, f(x(x), x0, y0, f(y), x0, y0, minus fxy, x0, y0, power 2. I can say here, if p more than 0 and f(x(x), x0, y0 more than 0, then you have local minimum at x naught, y naught. First one. Second one. If d more than 0 and then f x x x naught y naught less than 0, then you have a local maximum at x naught, y naught. And if d less than 0, then f has a saddle point at x naught, y naught, and if d equals 0, then the second derivative test is conclusive. Do you remember this example? This one. We want to check this one without the graph, how is looking the second derivative. We know the critical points here. Let me copy this one. Okay, and let me copy the example. Okay. Let's find the second derivative. You know that the f of x, let me write the graph. F of x round after x to x3 plus x plus 1 y squared plus 5x2 would be equal to 6x2 plus y2 plus 10x. And fxx would be round after x, 6x2 plus y2 plus 10x would be equal to 12x plus 10. Now you know the fy is equal to round after y bracket to x3 plus x plus 1 y squared plus 5x2. It means that equal to x plus 1 y and fy y equal to y of the 2 x plus 1 y it would be equal to x plus 2 and fxy would be equal root of the y, f of x is equal root of the y, f of x is 6x2 plus y2 plus 10x equal to y. Now if I make a table, I can write here points fxx, that would be 12x plus 10, fyy, that would be 2x plus 2, fxy would be 2y, and d. What is the d? Is fxx, fyy minus fxy. And now classification. Okay. What point that you have, this 4 point that you find it before, is 0 and 0, minus 5/3 and 0, and minus 1 and 2, minus 1, minus 2. Okay. Let's see how this looks like. Okay. Now, I put here is 12x. I put here x0, y0. It would be here 10, would be here 2, and 0. And 10 times 220, d would be 20 is more than 0. Look at C. D more than 0 and D more than 0, and for the fxx is more than 0, is fxx more than 0, this you have a local minimum. This one more than 0, this one more than 0, you have a local minimum. Now for here, if I put minus 5/3 would be minus 10 less than 0. Here is minus 4/3. Here is 0, is 40/3 more than 0. Look at here, fxx less than 0, d more than 0. fxx here, more than 0, less than 0, d more than 0. Local maximum. Okay, now here is minus 2, minus 2, 4, minus 12 less than 0, minus 2, minus 2, minus 4, minus 12 less than 0. When is less than 0? When the less than 0, it would be saddle point. Here is the saddle point, and here is the saddle point again. It means that you don't need to have a graph. Without graph, you can, with the second derivative, you can find which point is the local minimum and local maximum. Next step to find the global maximum and sorry, global minimum. Okay. Sorry. How to find the global minimum and global maximum of a function. If you have just one variable, look like before, if I show you such a this, it's x and y equal to f of x. You can see this is the highest point that you have. The highest point that you have is the local maximum, and the other high point are the local maximum. It's the global. Here is the global maximum, the higher point, but this point is the exactly maximum, but it's not the highest point. Is local maximum, and here is local minimum. To find the global extreme of f of x on a and b, we consider critical points and the end points of a and b. This means for function for two variables, for function of two variables f, x, and y, we should find the global extreme of f on a closed and bounded domain of D is R squared. You know, we should check the boundaries to find the global maximum or global minimum. First step, local or look of critical points. Second step, look at the boundary. For example, find the global extreme of fx and y equal to x plus x plus y2 minus 2 under this domain x and y r square and x2 plus y2 less than or equal 4. This is your domain. Step 1, find the critical point. Consider the critical points. And you know, for to find the critical points, you should find the derivative of respect to the x and derivative respect to the y. I write f of x round of the x to x2 plus x plus y2 minus 2 would be equal 4x plus 1. If I put equal 0, then x would equal minus 1 over 4. And f of y is equal round of the y to x2 plus x plus y2 minus 2 equal 2y. If I put equal 0, then y is equal 0. Now your critical point is minus 1 over 4 and 0. And if I put f minus 1 over 4 and 0, you have an answer minus 17 over 8. Now we restrict the boundary. Let's see how is boundary looking. Okay, step 2, restrict f to the boundary of D. If I plot this one, it would be the circle that the radius is 2. It means that the less than or equal to, it means that the this, and you know that the minus 1 or this one minus 1 over 4 and 0 is a critical point. It's located here, but you should check the boundaries again. You know that the front of the D is equal to domain, I mean x2 plus y2 equal 4, and this is the edge of the, this is the edge of the scans. Okay, now for the find the to find the global maximum or global minimum, you should find the you should find the domain, critical point on the domain. Okay, let's see what should we do. You know that the f of x and y is equal to 2x2 plus x plus y2 minus 2, and also x2 plus y2 equal 4 is the critical point for the boundary. Now, it means that the y2 is equal to 4 minus x2. Now back to this equation, I can write f of x and y is equal to x2 plus x, 4 minus x2 minus 2. It means that the x2 plus x plus 2. And if you solve this one, x would be 9, and x should be in between minus 2 and 2, as here, minus 2 and 2. Now, if I call this one as a g of x, new variable, it means that the g prime of the x, d over d of x is x2 plus x plus 2. It means that the 2x plus 1 equals 0. It means that the x equal minus 1 over 2. G minus 1 over 2 would be equal to square root of the 15 over 4. Now you have another 2 critical point. It means that the f of minus 1 over 2 plus and minus 15 over 4 would be 7 over 4. And for the 8th point, g2, g minus 2 would be equal to minus 2 power 2 plus minus 2 plus 2 would be 4. And here would be 2 power 2 plus 2 plus 2 is equal 8. It means f2 and 0 is equal 4, and f here is minus 2 and 0 is equal 8. You have some point of this, you find this point, you find this point, and also you find another point here, this point. Then you can use the second derivative or graph to find which one is the maximum or which one is the minimum and which one is the global maximum. But look at here, without the use the graph, you see this one is the highest one, highest the number that you have. Yes, I can write this one is the global maximum, is the highest number that you have. Okay, let's do some in the calculus 8 chain rule. It's the important part, and keep the time. Okay, chain rule. The chain rule for the function of one variable you had before, you write the f or u x is equal f u x, and you can write d of over dx is equal to df over du equal times by du over dx. Now for more than one variable, more than one variable, you have a f equal fxy equal fx set up a st and y is the set of the another variable. I can write df over dt is equal to df over dx, dx over dt plus df over dy, dy over dt, and also derivative of s is equal to df over dx, dx over ds plus df over dy, dy over ds. Okay, let's see how is this one exactly looking. Okay, function of two variables. You have a z depends of the u and u depends of the x and y. It means you have a z of u and u of x and y, two variables. It means you have a z, u, x, and y. I can write here, then run the z, run the x is equal to run the x, z, u, x, and y. That would be equal to run the z, run the u, x, and y time round of the x, u, x, and y. It would be equal to round of the z, round of the u, round of the u, round of the x. For example, round of the x, sine x2 plus xy minus y3. I can write this one as equal to round of this one, cosine x2 plus xy minus y3. I can call this one round of the z, round of the u, times by round of the x, x2 plus xy minus y3. I can write round of the u, round of the x. It would be equal to cosine x2 plus xy minus y3 times 2x plus y. Is look like equal zu equals sine u. Zu equals sine u. This is the u. And u as x and y is equal to x2 plus xy minus y3. Okay. There is some rules for the chain rule. I start to explain for them, but I start from the chain rule number 2 because it's simpler than the rule number 1. Chain rule number 2. If you have a z, then you have a u, you have a 1x, you have a 1y. I can write dz dx is equal dz over du over dx and dz over dy dz over du over dy. It means that here dz over du here is du over dx and here is du over dy. Chain rule number 2. Number 1, sorry. You have a z, you have a x, you have a y, each one has a t variable. You have a z, xy, xt, and yt. Now we want to find dz over dt. Okay. Now we want to find what is dz over dt. It means limit delta x to delta z over dt. We use the small change formula to find that one. A small change formula from the last session. You know that the delta z is equal to front of the z, front of the x, delta x plus front of the z, front of the y, delta y. It means that I can write here delta z over delta t from the z, from the x, delta x over delta t plus from the z over from the y, delta y over delta t. And now limit delta t 0 from delta z over delta t is equal to limit delta t close to the 0 from the z from the x, delta x over delta a plus from the z over from the y, delta y over delta t. Okay. It means the limit for the each part, it would be equal to from the z over from the x, limit delta x over delta t, when delta t close to the 0, plus from the z over from the y, limit delta t close to the 0, delta y over delta t, and at the end you have a from the z, from the x, dx over dt, plus from the z over from the y, dy over dt, and it would be equal to dz over dt would be equal to rho z rho x dx over dt plus rho z over rho y dy over dt. It means that here you have rho z rho x rho z rho y dx over dt dy over dt. Now change rule number 3. You have a z, x, y, and each z has a s, t, s at. For here, you have a rho z over rho x, rho z over rho y, rho x over rho s, rho x over rho t, rho y over rho t, and rho y over rho s. It means that the rho z over rho s would be rho z over rho x over rho s plus rho z over rho y over rho s, and rho z over rho t would be equal rho z over rho x over rho t plus rho z over rho y over rho t. And they have a general rules for the chain rule. General chain rule. For example, you have a 1z, x1, x2, x3 to xn, and then you have a t1, t2, t3, tn, but again they are all connected to each other, such as this. It means that rho z, rho ti is equal to rho z, rho x1, rho x1, rho ti plus rho z, rho x2, rho x2 over rho ti plus, it means that equal to summation j equal 1 to n rho z rho xj rho xj rho ti. Okay, now some more example. Z, x, and y equal square root of the x2 plus y2 or I can write x2 plus y2 1 over 2. Okay. I want to use chain rule number 2 to solve this one. Chain rule number 1. Sorry, number 1. I can write here run the z over run the x is equal run over run the x, x2 plus y2 power 1 over 2. It would be equal to 1 over 2 x2 plus y2 power minus 1 over 2x, and round the z over round the y is equal round over round the y x2 plus y2 power 1 over 2. It would be equal to 1 over 2 x2 plus y2 power minus 1 over 2 2y. Now also when x of the t is equal cosine t and y of the t is equal t plus e to t. Like you have these two, and also you have xt equal to cosine t. It means that the dx over dt is equal to minus sine t. Then you have a yt is equal to t plus e 2t. It means dy over dt, it would be equal to 1 plus 2e to power t. And what is the chain rule number 1? Is this one. I copy this one. Paste here. You can see you have a run the z, run the x. Yeah. You have a run the z, run the y. Yeah. And you have a this one, dx over dt here. And you have a dy over dt here. You just need to put the equation. I write here dz over dt is equal to 1 over 2 x2 plus y2 2x power minus 1 over 2 minus sine t plus 1 over 2 x2 plus y2 minus 1 over 2 2y 1 plus 2e 2t. It would be 1 over 2 you can factorize here would be cosine power 2t plus 1 plus e power 2t power 2 to cosine t minus sine t plus 1 over 2 cosine power 2t plus t plus e to t power 2 plus times 2 t plus e to t times 1 plus 2e. Okay, I put x and y as a cosine and 1 plus E 2T. Okay. Another example. I want the chain rule number 3 to solve this example. Z, X, and Y equal X2 plus sine XY, X, T, and S equal T2S, Y, T, and S is equal S3. Now, what is dz over ds? You know that from the chain rule number 3. Run the z. Okay, right, better here. Run the z over s. Run the z over run the s would be equal to run the z over run the x plus run the x over run the s plus run the z over run the y over run the s. I can write this one as equal round after x, x2 plus sine xy, and this is the times here, times round after s, t2s plus round after y, x2 plus sine xy, round after s, s3 would be equal to 2x plus cosine xy y t2 plus cosine xyx times 3s2. Okay, it is the some summary for the calculus 7 and 8. Let me check the page everything. Yes. And it is about the local, global, and maximum. You know that first derivative, you find the minimum, local minimum, and maximum, and second derivative, you can find each location depends of the each number, and you can find the saddle point. Then you can find the global maximum and minimum for the global and maximum and minimum. Then you should use the first derivative, find the critical point, and also boundary. And they have chain rule for the chain rule. It looks like the one variable, but you need to add the you make some chart for yourself. For example, put the z depend of the u, x, or t, or x depend of the t or s, or separate. It's very easy. You just need to put each derivative in each position. It's enough for today. Do you have any questions?
Oh, no, thank you.
Okay, I saved the slide on the tutorial support, and also you can see the video there as well. I'm already recording. If you have any question, you can send an email to me at any time that you want. Okay, have a good weekend, and I will see you next Thursday as well. Okay, bye-bye.
Okay, thank you, guys.